See, in the last class, we already saw the concave mirror and derived the mirror equation for the concave mirror. And we derived the equation as follows. So this was 1 by u plus 1 by v is equal to 1 by f, which is of course equal to 2 by r. Okay, so r is the radius of curvature, f is the focal length, u is the object distance, v is the image distance. So then we discussed that this equation, although we derived it for the concave mirror, it also applies to the convex mirror. And why is that the case? Okay, so we said that the same equation could be used even for the convex mirror, and the reason is that we will follow these strictly follow these sign conventions. So when we apply the mirror equation, as long as we follow these sign conventions, the same equation can be used both for the concave as well as for the convex mirror. Okay, so concave mirror, we already saw that it is 100% applicable. The convex mirror, if we want to use it, we need to follow these sign conventions. So what are the sign conventions? The sign convention says that the object distance and the image distance, these are positive when the object or the image lies in the front of the mirror. So this is the front of the mirror, this side. Okay, this is the front of the mirror. Okay, and the image and the mirror is it has been silvered like this. Okay, so this is of course the convex mirror, so it is silvered like this, and this is the front of the mirror. So as long as the object and the image are in the front of mirror, whether the mirror is convex or concave, the u and v, we take them as positive. Okay, so this is positive, and if the object or image is in the back of the mirror, it comes out, then we take the u and v to be negative. Now what does it mean by negative u? Okay, so negative u and negative v. So negative v, understanding it is simple, right? So you have done some computation, you have computed your value of v, and in the end you see that this value actually comes out to be negative. Now when this value comes out to be negative, what does it mean? It means that the image is not formed in the front of the mirror where the light rays are actually coming. So this is the lighted region. The image is not formed in this region, but the image is actually formed in this region. That means that the image is virtual. So if you when you do the computation and your image distance, it comes out to be negative, it means that it is a virtual image. Okay, so that part is simple. Okay, what about the negative object? How would we ever place the object on this side of the mirror, on the back side of the mirror? How would we ever place the object like that? So how can the object distance be ever negative? See, when we are solving the questions in which the image, multiple mirrors and multiple lenses are involved, in those types of questions, sometimes your object for one mirror would come out to be on the back of the mirror, right? So that would be the image formed by one of the other lenses and the mirrors, and that image would be formed at the back of this mirror. And because that image is in the back of this mirror, when we do the computation for this particular mirror, we will say that the object of this mirror, okay, so that image would act as an object for this mirror, and we will take the object distance in that case to be negative, and then from there on we would compute our image distance, what would be the image formed by this mirror. Okay, so the object would be negative only when multiple lenses and mirrors are involved. Okay, otherwise for a single mirror you are correct that this could never be possible. Now the image height, we already discussed this. The image height, when it is upright, when the height is upright, image and the object height, they are taken to be positive when they are on this side of the principal axis. When the object and image are on this side of the principal axis, then they are taken to be negative. The heights are taken to be negative. Now focal length and radius, this is something that we have to remember. This is positive if the mirror is concave. Okay, so that is what we were dealing with so far in the last class. We dealt with concave mirror, and we took the F and R to be positive, and it is always negative if the mirror is convex. Okay, Another thing is that this is a sign convention for mirror. For lenses, there is a separate sign convention which we'll study in a later class. Now, magnification. Again, this is something that we have computed already. So, magnification, the image is always upright and the image is always inverted. So, when the magnification comes out to be positive, both the image and the object were upright. When the image is inverted, of course the object we will always put in this location only. Why would we put it in another location? Okay, the object is always upright. So if the image is inverted, then the magnification comes out to be negative. That is a natural consequence for this. Okay, due to this sign convention that we are following for the images, when image is inverted, the image is negative, and because image is negative, the magnification comes out to be negative, because it's the ratio of the image height to the real height. Okay, and that's something that we studied in the last class. Of course, these sign conventions will become even more clear as we solve problems based on this in the next class. So definitely subscribe to the channel, because ultimately we want to be able to solve numericals using this sign convention, and that too with multiple mirror problems. Okay, thank you.